This is CPM Calculus Chapter 4, number 130. Here we're asked to evaluate four limits. So A, we're given the limit as x approaches 9 of square root of x minus 3 over x minus 9. So when we're given as a limit as x approaches some constant, the first thing to do is to plug it in and see what happens. So this is just square root of 9 minus 3 over 9 minus 9, right? So maybe you've seen this before you plugged it in, so you don't do this, because you're going to see this is just 3 minus 3 over 9 minus 9, which is 0 over 0. And remember, this means not 1, right? This means indeterminate, undefined, so we need to do more. We need to investigate further. So undefined means investigate further. Right? So let's go ahead and investigate this. Can we go ahead and rewrite this or do something to our expression here so it looks better, right? Well, I can see right away that if we let me say something here. Let's let, I don't know, some variable u is equal to square root of x, right? Then if we square both sides, we're going to have u squared is equal to x, right? If u is square root of x, u squared is x. So let's go ahead and let this happen, right? And then go ahead and do the rest. So instead of x, we're going to have u squared. It was approaching 9, right? Because we had x here. And here we're going to have square root of x. So it's u minus 3 over x minus 9, but x we had is u squared. So I'm just rewriting this using substitution for u. Alright? So maybe you've seen this already. So that's the same as the limit as u squared is approaching 9. And then in the numerator we have u minus 3, but the denominator we can factor, right? This can be u plus 3 and u minus 3, right? This is the difference of two squares. And now we can see that these two cancel out. So that's equal to the limit as u squared approaches 9 of 1 over u plus 3. Alright? Now we can go ahead and substitute back in our values for u, for x. So this is the same as limit, again, u squared was x. So the limit as x is approaching 9. And this is going to be 1 over u, well, that's square root of x plus 3, okay? And now if we plug in 9, that's just 1 over square root of 9 plus 3, or 1 over 3 plus 3, which is 1 over 6. So our answer here is 1 over 6, okay? If you wanted to, you could have done this all without these steps, right? So I could have, I'm just going to show you really quickly. I could have seen right away that if I plug in 9, I'm going to get 0 over 0. I'm going to need to investigate further. So I don't really need to do this if I can plug it into my head and see that this is going to be necessary, right? And I don't even need to let u equal to square root of x. I can go ahead and say, well, this is the same as limit as x is approaching 9 of square root of x minus 3 over, if I can see this as the square root of x plus 3, the difference of two squares already, as square root of x plus 3, square root of x minus 3, I could just go straight from there to there, right? And then I can see that these cancel out, and then I go from this step to here, and then from here to go ahead and finish it off. Okay, so I just want to show you that sometimes some steps you can do in your head, right, and save yourself some time, but you're going to need to make sure you understand this before you go ahead and move on. Because if you don't see this, then you don't want to skip that step. Okay? Let's go on to part B. Part B, we have the limit as h goes to 0 of square root of 2 plus h minus square root of 2 over h. Alright? So right away, I know that if I plug in h is 0, I'm going to get 0 in the denominator, and that means investigate further. Right? I don't need to plug anything in because I see it right there, right? In the numerator, the same thing. I'm going to get square root of 2 minus square root of 2 is 0. So this means investigate further, right? Unlike the previous one, I don't see the difference of two squares, but I see square roots. So I'm going to go ahead and multiply by the conjugate, right, to go ahead and get rid of some of those square roots. The conjugate is just going to be the same thing, but instead of a minus, it's a plus. So that's the square root of 2 plus h plus square root of 2. But again, I can't just multiply by some random value unless I multiply that same random value in the denominator, because then this whole thing is 1, right? Same in the numerator as denominator, so this is multiplying by 1, and we know we can always multiply by 1 without changing the value, okay? So that's equal to the limit as h approaches 0. Let's go ahead and multiply the numerator. The first terms, right, that's going to be square root of 2 plus h times the square root of 2 plus h. So that's just going to be 2 plus h. We get rid of the square root. We're going to multiply then the first and this term, right? First and last term. That's going to be square root of 2 times square root of 2 plus h. Well, so that's going to be square root of 2 times square root of 2 plus h. So that's inside the square root is 2 times 2 plus h, or 4 plus 2h. Okay? Plus, let's go ahead and multiply these two terms. That's negative square root of 2 times 2 plus h. That's going to be negative square root of 2 times 2 plus h. I'm going to put that 2 in the inside just like I did here. So it's 4 plus 2h. I don't need to do that. I could have left the square root of 2 out here, because these you're going to see are the opposites and will cancel out in just a second. And finally, the last two terms, right? Negative square root of 2 and square root of 2 is going to be minus 2, right? That cancels out. In the denominator, we just have h times square root of 2 plus h plus square root of 2. I'm going to leave it like that because these are going to cancel here. And I'm going to simplify it now. Limit as h goes to 0 of 2 minus 2 cancel out as well. So it's just h over h times square root of 2 plus h plus square root of 2. Magically, wow, well not magically, but we kind of knew this when we multiply the complex conjugate. We're looking for this cancellation right here. So the h over h cancels, and we're left with the limit as h goes to 0 of 1 over square root of 2 plus h plus square root of 2, right? And that's just equal to, we can plug it in. So when we plug it in, we no longer use limit. It's just 1 over square root of 2 plus 0 plus square root of 2. And that's equal to 1 over square root of 2 plus square root of 2, which is 1 over 2 square root of 2. All right, so here's our answer. Usually we do not like square root of 2 in the denominator. So let's go ahead and multiply this by square root of 2 over 2, which make this 2 in the denominator. So 2 times 2 is 4. So it's square root of 2 over 4. Okay? All right. So this was a cool problem. Just remember to always multiply by the conjugate over itself to equal 1. Because remember, this was 1, which was conjugate divided by conjugate. Okay? Let's go into part C. Part C, we have the limit as x approaches infinity of this expression over this one. Right away, we can't really plug in infinity, but if we went ahead and did that anyway and like thought about it, this would be 2 times the square root of infinity plus 1 and 5 minus the square root of infinity, right? So we're going to get a really big number in the numerator over a really big negative number in the denominator. So what we could do though is rewrite this, right? Instead of the square root sign, let's go ahead and write it as power. So this is the 1/2 power plus 1. And I'm going to write this power in the front. So this is negative x to the 1/2 power plus 5, right? Because when we look at x approaching negative infinity, we can go ahead and look at the biggest power of x, which is x to the 1/2, and then it's going to equal to the coefficients in front of those two powers if they're the same, right? Since they're the same, we're just looking at the coefficients, so that's 2 over negative 1 or negative 2, okay? If you didn't see that right away, because the answer is negative 2, what you could do then is multiply this. So I'm going to start here. Imagine you didn't know this. So put this in a bubble. You can go ahead and multiply this. This is why it's true. By 1. But you want to represent 1 as 1 over x to the 1/2 over 1 over x to the 1/2, right? That's multiplying by 1 because those are the same, right? And the reason why we did this is because then we're going to have to distribute this to all the terms that we're multiplying by. And that's equal to limit as x approaches infinity, 1 over x to the 1/2 power times this, so that's 2x to the 1/2 times 1 over x to the 1/2 plus 1 over x to the 1/2 all over, and in the denominator we're doing the same thing, negative x to the 1/2 times 1 over x to the 1/2 plus 5 over x to the 1/2. Okay? Simplifying that, we get limit as x approaches infinity. This right here, let me use another color. This right here is equal to 1, just like this is equal to 1. So we get 2 times 1 plus 1 over x to the 1/2 power over negative 1 times 1 plus 5 over x to the 1/2 power. Okay? Now when we take the limit as x approaches infinity, we can't plug in infinity, but we can go ahead and look at that. We're going to have 2 times 1, which is 2, plus 1 over the square root of infinity, right? 1 over the square root of infinity. 1 over the square root of infinity, well, x, if this is infinity here, the square root of infinity is still infinity. So 1 divided by that infinitely big number is 0, right? Here we have negative 1 times 1 is negative 1. 5 divided by an infinitely big number is 0. So there's where we get our 2 over negative 1, which is negative 2, right? Just like we got here right away, okay? Finally, let's go on to part D. Part D says the limit as x approaches infinity of cosine x. All right, this is a great problem because basically, if we look at cosine of x, right, what's happening is going up and down, up and down, up and down, up and down between 1 and negative 1, right, forever and ever. So as x approaches infinity, if we're looking all the way to the right, it's still going up and down, up and down, and up and down. So the limit is x approaches infinity of cosine x. There is no limit. No limit. Right? Does not exist. Alright? Because cosine of x still oscillates between negative 1 and 1 forever. Right? So no limit does not exist either way. Okay? And this is the reason right here. So that's all 4 parts. So that ends CPM Calculus Chapter 4, number 130.